Does a wave actually dance? Hold up. Let me explain. Okay, so whenever we talk of a wave, right, this is a way in which we can move energy from point A to go to point B. And this can happen through various means, but the overall point is that energy must be transferred. So we might make use of things that we call particles, right? We're going to use particles so that energy can be able to transfer from point A to point B. Right? But that's different. These particles can be air particles, can be water particles, depending on whether you need a medium for propagation, right? So we're going to compare those kinds of transverse and longitudinal wave. So the way you can think about this is that for transverse, the particles move in a certain way, but they still propagate energy. For longitudinal waves, the particles still move in a certain way, but they still propagate energy. So if you want to understand this, let's think of it this way. Imagine your particle is represented by a person. Like your particle is represented by an individual, right? And then you put other individuals after that person, right? So multiple individuals, you layer them, and then you ask those people to dance. But you want them to dance, and they're carrying a bag of, what can we say, a bag of chips, for example. So they want to move a bag of chips from point A and arrive to point B. So how that's going to work is going to be different. So this group of people, the first one, they're more fun. So the way they dance is that they move forward, cha-cha-cha-cha-cha, they go back, cha-cha-cha-cha-cha. Right? So as they do that, as one person moves back, they take the bag of chips. The other person is moving back so that they can receive that bag of chips. Then they move forward. So it's back and forth, back and forth, back and forth. And you see that the packets of chips has been moved from point A to arrive to point B, right? So they're dancing back and forth, back and forth. A very, popular dance style, right? And as they're doing that, they're able to transfer energy. If we're relating this to particles will be able to transfer energy from point A up until point B. And these, my friends, are referred to as longitudinal waves. Okay? These are referred to as longitudinal waves, where energy, the particles themselves, actually vibrate, they dance parallel to the direction of wave transfer / energy transfer. So they're dancing parallel to that direction, right? And this can look in different ways. So compression, right? It can be through compression when the particles are closer together, right? And the air pressure is higher than the surrounding air pressure, right? Or it can be rarefaction, where the particles are further apart, right? So they compress, they go refraction, compression, refraction, and as that continues to happen, we can say that is a longitudinal wave. But if you have another dense style, right? If you look at from point A to point B, there's a different group of people, right? They have more vibe, but these ones are doing it a little bit differently. You give them a bag of chips up until point B, but how they're doing it is just a little bit different, right? So what they do is they take the bag of chips, they start, the music plays, right? They go up, they pass, they go down, they pass, they go up, they go down, they pass, and the energy is actually transferred from point A up until point B. But how that's happening is that, as you can see, the particles are actually moving perpendicular. Perpendicular means forming 90 degrees, guys. The particles are actually moving perpendicular to the line of wave motion. And as that happens, we can easily say that is what we call, guys, that is what we call a transverse wave. Right? So we've made a comparison between transverse and longitudinal waves. So we'll first start with transverse, right? And for transverse, the direction of wave transfer, right? And for longitudinal, the opposite actually happens. So for transverse, the direction of wave energy transfer is actually perpendicular to the vibration of those particles. But for longitudinal, it's actually the opposite. The direction of wave of energy transfer, right? And then another difference is that longitudinal waves cannot be polarized. It's polarization, meaning restricted motion in a specific plane. Now, if I were to explain that, this will make this video extra long. So for you to understand polarization, I highly recommend that you watch my videos. Go on my channel and you see a will explain detailed video about polarization, where I explain why is it that longitudinal waves cannot be polarized. But for transverse, they're cool. They can be polarized, right? they can be have restricted motion, right? And you're going to see in that video why transverse waves can be polarized. So highly recommend that you watch that. I really hope that it makes sense and you're able to grasp something that is very important. And remember, waves can dance. It's just that they're bad, right? They can dance up or down, left or right. But in simple terms, it means that these particles are free to move in specific directions with the aim of moving energy from one point to another. Remember that. And I will see you in the next one.